The night sky has always been a mirror of human curiosity. For thousands of years, people looked up and searched for meaning among the stars. One of those stars always stood out like a glowing ember in the darkness. That star is Betelgeuse, a massive red supergiant that forms the shoulder of Orion. To ancient civilizations, it looked like a cosmic fire burning quietly in the distance, an aging king of the stars slowly approaching its final breath. For centuries, astronomers believed its story was simple. It was a giant star reaching the end of its life, swelling outward as it burned the last of its nuclear fuel. But modern astronomy has revealed that the universe rarely tells such simple stories, and the true story of Betelgeuse is far more dramatic than anyone imagined. What scientists have recently discovered has forced them to rewrite everything they thought they knew about this legendary star. Instead of being a lonely giant fading quietly, Betelgeuse may actually be part of a hidden cosmic relationship, one that changes our understanding of how massive stars evolve and die. This revelation begins with a strange mystery that puzzled astronomers for more than a century. During the 20th century, telescopes became powerful enough to study Betelgeuse in greater detail, and what scientists saw didn't make complete sense. This star is enormous, so large that if it replaced our sun, its surface would stretch far beyond the orbit of Mars. Yet despite its gigantic size, the star behaved in unpredictable ways. Its brightness would suddenly change. Its surface appeared uneven and unstable. At times, it looked as if the star was pulsing like a giant heartbeat across space. Then something even stranger happened. In 2019 and 2020, Betelgeuse dramatically dimmed in what scientists later called the Great Dimming of Betelgeuse. For a moment, many people believed humanity might be about to witness a spectacular cosmic explosion. A star like Betelgeuse is destined to end its life as a supernova, and when it does, the event will shine brighter than entire galaxies. But the explosion never came. The star slowly brightened again, and astronomers were left with a deeper mystery. Why had Betelgeuse dimmed so dramatically? What invisible force was affecting one of the most famous stars in the sky? For decades, scientists proposed different explanations. Some believed the dimming was caused by gigantic clouds of dust ejected from the star's surface. Others believed massive convection cells, bubbles of hot gas, the size of solar systems, were rising and collapsing across its surface. These theories seemed reasonable because red supergiants are known to be chaotic and unstable. But none of the explanations fully solved the puzzle. Betelgeuse continued to show behavior that didn't match predictions. It seemed to lose mass faster than expected, and its outer atmosphere appeared strangely distorted, like a boat cutting through water. It looked as though something was leaving a trail behind it. This strange phenomenon would eventually lead scientists toward one of the most surprising discoveries in modern astronomy. But before they reached that breakthrough, they first had to follow a long trail of misleading clues, what scientists would later call the red herring of the Betelgeuse mystery. The red herring was the idea that Betelgeuse was completely alone. For most of astronomical history, scientists assumed the star was a solitary giant drifting through space. But many stars are not alone. They exist in binary systems, gravitationally bound with a partner star, locked in an eternal cosmic dance. If Betelgeuse had such a partner, it could explain many of the strange effects astronomers were observing. But detecting a companion around such a massive and bright star is extremely difficult. The glare of Betelgeuse hides nearby objects like sunlight hiding a firefly. For years, astronomers searched for evidence of a companion star, but found nothing convincing. Without proof, the theory faded into the background and scientists returned to studying Betelgeuse as a single star slowly dying in isolation. But then new technology arrived on new telescopes, new imaging methods, and new computer simulations began to reveal details that had never been visible before. And hidden within those new observations was a clue that changed everything. The breakthrough came when astronomers began studying the surrounding environment of Betelgeuse in unprecedented detail. Using powerful space telescopes and advanced infrared imaging, scientists observed something extraordinary around the star. They detected enormous arcs and structures of gas stretching far into space. These structures looked like waves spreading outward from a moving object, almost like the wake behind a ship traveling through an ocean. This discovery suggested that Betelgeuse might not be standing still. It might actually be plowing through interstellar gas at incredible speed. But more importantly, the shape of the wake suggested that another object might be interacting with it. Gravitational forces can shape gas and dust in complex ways, and the patterns around Betelgeuse hinted at the presence of an unseen companion. Suddenly, the old assumption of a lonely star began to crumble. The evidence suggested something far more interesting was happening, deep within the glowing clouds surrounding Betelgeuse. Once astronomers began considering the possibility of a hidden companion, the puzzle pieces started to fit together. The strange variations in brightness, the unusual mass loss, the mysterious dimming events. All of these could be explained if Betelgeuse was interacting with another star through gravity. If such a companion existed, it would periodically pass through the outer atmosphere of Betelgeuse, disrupting gas flows and triggering violent eruptions of material. These interactions could create huge clouds of dust that temporarily block the star's light from our perspective on Earth. Suddenly, the great dimming of 2019 looked less like a random accident and more like part of a repeating cosmic process, and that process may have a name scientists now call the Siwarha Event, an interaction phase where a companion star begins to plunge deeper into the outer layers of a red supergiant. This moment marks the beginning of a dramatic transformation in the life of the system. To understand this process, we need to explore the physics behind it. When two stars orbit each other, their gravitational pull creates powerful tidal forces. These forces stretch and compress stellar material like invisible hands, shaping cosmic clay. In the case of Betelgeuse, the outer atmosphere is already enormous and loosely bound. Companion star moving through this region would experience something called gravitational drag. As it travels through the dense gas surrounding Betelgeuse, the companion star loses energy, much like a spacecraft, slowing down in a planet's atmosphere. This drag causes the orbit to decay, slowly over time. The companion spirals inward closer and closer to the giant star. This process is known in astrophysics as orbital decay, and it can dramatically reshape the evolution of both stars. The once stable orbit gradually shrinks until the companion plunges deep into the outer envelope of the red supergiant. As the companion moves inward, it begins entering what scientists describe as the feeding phase. This stage is one of the most violent and fascinating processes in stellar evolution. The smaller star begins to capture gas from the outer layers of Betelgeuse like a cosmic predator feeding on its giant host. Streams of glowing plasma spiral toward the companion, forming a brilliant accretion disk that radiates intense heat and energy. This feeding process can eject huge amounts of matter into space, creating massive clouds of dust and gas. These clouds may be responsible for the strange dimming events observed from Earth. They also shape the surrounding nebula into complex arcs and wakes that astronomers can detect with powerful telescopes. In other words, the environment around Betelgeuse becomes a battlefield of gravity, gas and radiation where two stars are locked in a dramatic interaction that will ultimately determine their fate. The implications of this discovery are enormous. If Betelgeuse truly has a hidden companion currently spiraling inward, it means the star's final explosion could be far more complex than scientists once believed. When massive stars explode as supernovae, the details of their internal structure determine the brightness and shape of the explosion. Companion star embedded within the outer layers could dramatically alter that process. It might strip away huge portions of Betelgeuse's atmosphere before the explosion occurs, or it could trigger additional eruptions that reshape the star long before the final collapse. These interactions could produce unusual supernova signatures that astronomers have observed in distant galaxies but never fully explained. In this way, Betelgeuse could become one of the most important laboratories for understanding how massive stars die and how binary interactions influence the most powerful explosions in the universe. For now, Betelgeuse continues to burn in the shoulder of Orion, a glowing red beacon visible even to the naked eye. Its light began traveling toward Earth more than 600 years ago. Long before modern science existed, each photon arriving at our eyes tonight carries information from a distant past when empires rose and fell on our planet. And somewhere inside that ancient light may be the story of two stars, slowly moving toward a cosmic collision. Astronomers continue, watching carefully using the most advanced instruments humanity has ever built. They are searching for subtle motions, changes in brightness, and hidden signatures that could confirm the existence of the mysterious companion. If the theory proves correct, the sky we see today is only the quiet beginning of a far greater drama unfolding hundreds of light years away. One day in the distant future, Betelgeuse will finally reach the end of its life. When that moment arrives, the star will collapse and explode in a supernova, so bright it will be visible even during daylight on Earth. For weeks, the night sky will glow with the light of a dying giant. A reminder of the incredible forces shaping our universe. But thanks to recent discoveries, the story of that explosion may be far more complicated than anyone once imagined. It may not be the lonely death of a single star, but the climax of a hidden partnership between two cosmic giants locked together by gravity. The discovery of the Siwarha Event has transformed Betelgeuse from a simple red supergiant into a dynamic and mysterious system, still revealing its secrets. And as astronomers continue studying this legendary star, they are reminded of a powerful truth about the universe. The more we learn, the more extraordinary the cosmos becomes.